Okay, let's continue on. Whoops, sorry. Made the screen go away there for a minute. Let's continue on with where we were. So we talked about the fact that we could have done this two different ways, so we're going to move on to the next slide here. So we're now asking for the total current here. So remember, we're going to have to apply several steps. The very first one is solving, since we want total current, we can solve total capacitance. So we got to first arrive at that value. So it's going to be product over sum. So we're going to take 500. I'm not using the pen again, which is making it a little awkward. So let's switch over 500 times 500 over 500 plus 500. And that's going to equal 5 times 5 is 25 with 4 zeros. It's going to equal 250,000 over 1,000. And we can mark off the last 3. So that's going to be 250 microfarads is our total capacitance. So our CT is equal to 250 microfarad. I apologize for the wonky little markings there, but this is microfarads. So let's do the 1 over 2 times pi frequency and capacitance. So that's going to give us 1 over 2 pi, and frequency is 60 hertz, and then we're going to times that by 500 microfarads. Now remember, micro means we're talking millionths, so we've got to divide 500 by a million. You can trust your brain to do that, or you can use a calculator so we can get base units, because this formula is looking at base units. So that's 0.0005, so 3 zeros and a 5. So coming back to our, let's switch back to a pen here. And we'll say times, sorry, I got to get reoriented with the pen, 0.0005. So again, this is base units. Again, if hertz were in megahertz or kilohertz, and this were in millifarads or whatever, we wouldn't have to necessarily switch if they cancel one another out. But if lack of a better term, it's always best to use base units if we've got a mixture there. So let's whip out the trusty calculator once again. So we're now calculating the x sub c here, and we're going to say 2 times pi, which is 3.14, times 60 times 0.0005 equals, and we're going to reciprocate that, and it's going to be 5.3 ohms of impedance if we did that calculation right. So we come over here, x of c is equal to 5.3 ohms. Well, our applied voltage, I've got the calculator right in front of it, so let me get rid of it. Our applied voltage is 120 volts, so if we want to do the math here, we simply take 120 volts divided by 5.3 ohms, and we arrive at our current here, total current. So find the calculator again so we can do the math. I know the answer already just by default, but let's make sure it works out to the exact value. 22. That does not look right. So the question is, I see what I did wrong. And this can happen to you as well. I did the 500 on the C instead of the 250. So that's why my formula is incorrect. So let's wipe out this and let's just start again, because sometimes that's the best thing. I tell you what we're going to do. We're not going to start completely over, but we are going to resume up here where we were. And the problem was I just used the wrong value when I calculated my x of c. So when we did all this math up here, we came up with, and let's write it down this time, and that way we can refer to it and not have any mysteries. So we had an x of c here of 250 microfarads. So we applied the formula 1 over 2 pi fc. Well, where I messed up was I used just a single value instead of the total value. So if we redo this and say 2 times pi, and I'm going to pause the video to catch that call. As soon as I get the pause back, and we'll take up here where we are. Okay, so we're taking 1 times 2 pi, and of course, let me move the calculator so we can see the frequency. I believe it was 60. Yes, it was. So back down here, 1 over 2 pi times 60 times, and it should have been, instead of 500 like I did a moment ago, and hopefully you caught that kind of as it was happening, but I did not. So if we take 250 and divide it by 1 million, and again I'm doing this just to get us back to units and to be sure we're using the right number of zeros. That should be 3 zeros. So we'll write that here, and then we'll do the math on it. So that is 0.00025. So let's run that calculation, and this will be our impedance, x of c. So 2 times 3.14 times 60 times 0.12325 equals, reciprocate that, and we get x of c. Let's write that down so we don't lose, not x of c. Actually, it is x of c. I put this unit wrong, so let's fix that right. And I apologize coming back in and trying to catch these videos when I can. It's easy for me to make mistakes, but if I make mistakes, it confuses you guys. So this should not have been x of c up here. This should have been just simply c total. And that's where we're putting that value in right there. But we did arrive at x of c to be 10.61 ohms. So now we'll just apply Ohm's law, 120 volts AC divided by 10.61 ohms. And that's going to give us current. And we can already kind of tell what that answer might be just by 120 divided by 10 gives us close to 12, but it'll be a little less because of the add-on there. But let me switch over. Let's clear our calculator. 120 divided by 10.61 equals. And see, even though I was writing this stuff down, 11.3 is what we got. Even though I was writing it down, I still used the wrong value, and that's why it's got to be very careful. You can't hurry through this stuff. That was kind of what victimized me just now, or at least that's my excuse, and I'm sticking with it. But the answer is 11.3 amps. And if you'd had questions, this would have told you kind of a step-by-step for each one of those. And you see it uses pretty much the same way we did. It solved for C total, then it solved for X of C total, and then we divided that into the voltage and we got our current. So same answer, 11.3, and as we see, that is the correct answer. So let's clean the slate. Let's move to the next opportunity here. So we got the same thing now. I'm probably not going to do the math quite as up close and personal this time, simply because we should begin to start knowing what to do here. And we know the very first thing we've got to solve for is CT. So we're going to have to take, so CT, and take 3 times 6 over 3 plus 6, and that's going to equal 18 over 9, which equals 2. So CT equals 2, and that is microfarads. And I also notice we're in 1 kilohertz now. So that's going to change the picture a little bit, but as long as we use base units, it really won't matter about that. So we'll make sure we apply that when we're doing our next step here, which the formula for X of C, or X of CT, now that we're talking about, actually we're not, we're actually talking about, should have known, and this is one of those gotchas that I always like to point out to you guys. We're looking for just the voltage drop across C1. Now we do have to go ahead and do this. We could have done it individually, or we could do it total. It really doesn't matter, but if we'll go ahead and calculate total current, we can get the voltage drop across C1. So let's carry on. The good news is it works either way here. So let's go ahead and apply that formula. 1 over 2 times pi times. Now we got to use base units here. So it's FC. So this is 1,000 times, and we want to take this 2 microfarads and divide it by 1,000,000. So we're going to say 2 divided by 1, 2, 3, 4, 5, 6 equals, and that is 1, 2, 3, 4, 5 zeros after the decimal place. So let's write that down. I know I moved the calculator out of the way, but I recall that. Oops, got to go back to pen mode. A lot of switching back and forth here, so bear with me. So this is 0.1, put the dot there, 2, 3, 4, 5, and this is microfarads right here. So we're going to have to do that math here on our calculator. So we'll clear our calculator, and I'll bring the calculator over here so we can see our values. So we're going to say 2 times 3.14 times 1,000 times 0.1, 2, 3, 4, 5, and then 2 equals, and then we got to reciprocate that. So by doing that, we've arrived at an X sub CT here of 79 ohms. So let's write that down. X of CT equals 79 ohms. Now we just got one more step to get current, and then one more step after that to get voltage. So I'm going to write me a note, because I've got to pause the video here, but I'm going to write a note to calculate current, and then voltage drop, and we'll come back and do each of those in just a second for you, but a few minutes for me. Actually, this video is just about to end anyway. We're getting close to the 15-minute mark, which is what Screencast lets me do. So I'm going to go ahead and stop this video, and we'll actually start that with the next video. So stand by, and as always, if you have questions, see an instructor.